I'd like to introduce two guys here who are geologists, and they're here to talk about the geology of the Pacific Crest Trail. They have been doing this presentation ever since I've been coming to Kickoff in 2003, and it's probably my favorite presentation. And I get fascinated by this, and you guys are such an awesome job. So I'd like to introduce to you Paul Hacker. Nohawk. Why are you Nohawk? And I'd like to introduce to you our grand poobah of the ADZ, Strider, Greg Hummel. And
can you give another round of applause for Freefall, who's put together this great schedule of events? All right. Well, journey of 4.5 million steps.
5 million
is trying upon 5 billion. There's and one of the things we want to convey to you is you're going to be walking along rocks in one of the greatest cross sections of geology in North America and maybe in the world. You're going to walk across more varied geologic features than you can walk across in any other National Scenic Trail. I'll make that sticker right here. And possibly in any other 2,500 mile stretch anywhere in the world. In that you're going to cross, most of the ranges, you're going to cross the San Andreas Fault, you're going to cross the Sierra Nevada, you're going to volcano hop all the way to Canada, through Oregon and Washington, and Northern California. So it is an incredible variety of geology. We're going to try and give you some insights into a little bit what to look for and where some of these features are, and have some fun along the way.
Yeah, Greg told me, this 5 million step thing, we've had this discussion many times, and he calculates at
4.5.
Yeah, and I think I'm just 5.25, I figured, or maybe more. So
it's not my fault you're short.
All you short people realize that you're a lot tougher than these tall guys.
If I'm carrying more weight, everything's more heavier, right? The pack's bigger, the seat mag's longer, the jacket's bigger, it's more weight. My base weight, I can't get down to 8 pounds.
Yeah, but we're closer to gravity, so it's harder on us.
This is beautiful.
Yeah, and the other thing, Greg, this 5 billion step thing, or 5 million steps, he told me about this 12-step program. It sounded really easy.
Other thing we want to convey to you in that is that the Earth, to the best of geologic studies, is close to 5 billion years old. And the Earth has been going through an evolution, a rock evolution, and a rock cycles, tectonic cycles, for that 5 billion years. And it's not done yet. Japan's an excellent example of the geologic forces that are still impacting the world. And so the rocks out here that you walk on, that you just stuck your tent pegs into, they're not done. You pick them up, you think they're done. This is the end of their journey. They're not done. They're moving. Gravity sucks. Erosional processes are ongoing. It's all moving downhill, downstream to the Pacific here in this area and along Oregon and Washington. And everything is still moving. It's just in our lifetimes, they don't move very much. It's very rare to see geologic processes like Japan in human history, because in general they happen infrequently, or they happen at such a slow speed at geologic time that you can't perceive them.
Just like everything in nature, there's a cycle, and rocks go through a cycle.
We need to start.
Yeah, start doing it.
Yeah. So you guys know this stuff. That's a repeat of last night.
Wait a minute, that's important facts. Okay.
A little history, because you got to know where you're going. You're coming from before you know where you're going. film last night hit on this just briefly. Clinton C. Clark, a petroleum engineer. A lot of oil origins in this community.
Well, not everybody can be a geologist. Some people don't.
You have to be an engineer, yeah. He came up with the idea, well, he took the idea from a lady that had come up with it back in the 1930s, but he championed the idea. And he took the idea to Congress and was the one who personally, along with Warren Rogers, were largely responsible for Congress passing the National Scenic Trails Act. And he died just prior to that being passed. He never got to see it in his lifetime, but he was one of the earliest champions. We're now, me, other people here, the PCTA, are the champions that are carrying it now into the future and beyond that. And we're hoping you will step into our shoes and carry the torch beyond. So, 77, the year that we hiked, it was the change to the conference, to Pacific Trail Conference. And then in 92, it became what we all know and love now, the PCTA. So where does it go? You guys know where it goes, right? But you don't know what you're walking across. Yeah. So the first section, you're going across peninsula ranges. Those peninsula ranges have been formed by tectonics over probably the last 600 million years, are the features that you're seeing. Big,
all the
big
boulders we're seeing.
Big spans of time.
And these granites we're seeing here are probably related to the Sierra, and they've been broken by the San Andreas Fault and Carlock and all that movement.
Good.
Thank you.
Don't cut the screen.
I know.
You know, that brings to mind a question that I've got. You know, I hear that all of these trekking poles are putting a big dotted line across.
Yeah.
And that there's danger that the whole thing's going to...
There have been more far-fetched ideas that have come to fruition.
Greg and I have already thought about that, and we're buying beachfront property right along the
So, the San Andreas Fault runs and
Makes a big turn.
Yeah, it makes a big turn. This isn't dark enough for me to see it. Yeah, cuts through, and comes down.
Makes another turn.
Yeah.
So this, where this gets bound up, where the San Andreas makes this big turn, and the San Bernardinos kind of take this east-west orientation, that's where the turn is, and you'll see some great jumbled metamorphics and heavy ferromag, iron-rich heavy stuff, and yeah, everything here is all crumbled.
As you come across Fuller Ridge on the north side of San Jacinto, you look down at San Gorgonio Pass, and Palm Springs is off to your right, and Interstate 10's right in front of you running. That pass is two major splits of the San Andreas Fault, 2 or 3 splits of it. And the further the San Andreas Fault gets to the south, the more it splits into what we call horsetails. It starts to split into a bunch of different ones. As it runs to the north, it becomes a very finite line on the map, and it's more finite, let's put it that way. And you actually cross it 3 times?
I believe that's correct.
Yeah, 3?
Once.
1,
Twice. Thrice.
3 times, yeah. 3 times. And that's in the guidebook, and you can pull that out of the guidebook when you're crossing there.
So I would suggest not straddling the fault and relaxing.
No jumping up and down on it, okay?
Yeah, like we were talking about Japan earlier. They calculate an 80-foot shift at one point in lateral movement on that thing in 1 instant. Yeah.
This section of San Andreas Fault is what hasn't moved. It's from about there to about there. It hasn't moved
Since 1852.
1852.
It was about an 8.2.
The predictions of the big one have come from that, because it still hasn't moved. And we're now ticking into the future outside of the error window of that big one. and it's got all the earthquake science people very nervous in Southern California. It's coming.
However, comma, Greg mentioned something the other day. Because there's a significant amount of lateral displacement on the San Andreas, we're not likely to get the 9.0 kind of things that they saw at Sumatra and at Japan. So
That's really
we'll show you a
unusual.
little diagram what that looks like.
Yeah, subduction zone earthquakes can be huge, and Oregon and Washington could have that size of earthquake that Japan saw, because there's an active subduction zone creating those volcanoes in Oregon and Washington. Okay, so we're going to skip up Northern California. We're in the Sierras, of course. We should run through these quickly because we've got it.
Yeah, we got a lot to do. Okay.
Yeah.
So I'll finish going through the Sierras,
Gold country.
Gold Country, which is a metamorphic belt where all the gold low country, all 19
Just start to get to the active volcanoes. Lassen is the southernmost active volcano in the volcanic system, here in the Pacific Northwest volcanic system. And you take this big jog to the west and the Laurel Mountains around, and you get this great view of Shasta all the way around here. Paul and I hiked from there last year. And then you come back to the volcanoes in southern Oregon, and now you volcano hop. In other words, you go down to the forest, and you come up out of the forest to the shoulder of this volcano, and you see the next one. You go back down into the forest, you come back up on that one, and you see the next one. You turn around, and there's that one. And that was 2 days ago, that's 3 days away. And you go down, and you come back up in the next one, and you do that for a while through Oregon and Washington. Down. There it is. So, Crater Lake.
That's a volcano that blew its stack, right?
Yeah. Mount, I don't remember. Zama? Yeah, good, thank you.
Could somebody get those in the right order, because we
Three
screwed
Fingers
this up on
Jack,
National Geographic.
Mount Thielson's just north of it. It's a great spire. Three Fingers Jack, Jefferson, etc. As you march up towards
Monroe, Madison, no, those are,
Mount Hood, right?
yes,
Yeah, Mount Hood. And then you cross the Great Columbia Gorge. The Columbia Gorge is there for a geologic reason.
and
There's
the
been-
low point on the PCT.
And the low point of PCT, it's been shown that at the melting of the ice ages, there were some major floods that came out through the Columbia Gorge and scoured it so deeply through the massive salt flows from Mount Hood and other volcanoes in the area. And so that's why there's such a gorge there. And then you come up Mount Rainier is sitting
Somewhere in the island.
This gets really washed out.
Yeah.
Rainier's in here somewhere, just to throw them up. Yeah. And
Right there?
it's west of sort of west. And Mount St. Helens, in 77, we walked by Mount St. Helens, and Mount Adams is sitting there with a glacier cutting the volcano in two, and it's really fascinating to look at. Some great cascades and beautiful lands around it, forests and such. And turn around, there's Mount St. Helens. It's just a boring volcanic cone.
Perfect shape.
You know, we can go up to Rainier, we climbed Rainier in 77, and we're taking pictures, and I've got a picture of Mount St. Helens in the smoke, because there were forest fires all up and down the coast the year we hiked it, and it's just a little mist in there. Damn, I wish I'd taken better pictures of that mountain. Because 2 years later it went off, and so then you come up and get up into the Safety area, and Lake Chelan is a glacial valley. You get up into some really great glacial features, some really U-shaped features. that
It's
are
a really
glacially-
nice metamorphic.
Yep.
You can see where the boulders were stretched as the rock was stretched, and the boulders
Metamorphic.
were round and they're stretched out like little cigars. It's pretty cool.
So, this is what I said at the beginning. Trailcross is what is arguably the greatest exposure to geology, tectonics, and of course scenery, beautiful scenery in the world. So, of all the types of rocks, all you got to remember is basically there's only 3 types. Geologists really categorize rocks into 3 different categories, and these are the 3 different categories. Ingenious,
Igneous.
being volcanic rocks, intrusives, granites. This is mostly granite out here. There's some, obviously, in the ridge out here across Lake Marina, there's some sedimentary rocks. If you look out there, there's some red and white zones, and they're coming across, and there's a deep canyon on the ridge across over here, and there's a deep canyon on the right side of that ridge, and on the other side, the color is completely different than on the left side. It's a fault. There's no question it's a fault. This whole area is faulted up, and these are minor splits of the San Andreas and some of the shear that this whole area has done. Tectonic studies in this area has shown that most of these ranges have rotated as much as 90, 100 degrees in a left lateral and a clockwise rotation over the last 20 million, 30 million years. Anyway, so ingenious,
Metaphoric?
Metamorphic? Yeah, well, let's go sedimentary first.
Sedentary.
Sedentary, yeah. Sedentary.
There's the rocks that are just laying there flat, you know, they got eroded and they fell.
Most of the time when you see layered rocks, limestone, sandstone, shale laid out, those are sedentary. Got me doing it.
The oldest ones are on the bottom, usually unless they got flipped over, which happens.
Sometimes.
Yeah. And then the metamorphics, which are the altered rocks. They can be either sedimentary rocks or igneous rocks that have been altered by heat and pressure. And those you can kind of tell because they'll get all boogered up, and what a term we call fumar. But you know the breed. Okay.
So, in the history of geologic history of the world, a single rock, if you pick up a rock here, it's been on a 4.5, 5 billion year journey, right? And over that journey, you could pick just an arbitrary little quartz grain out of that granite. And if you could open it up and read its history, it would have started out here, gone to here, gone to there, probably gone back to there, gone back to there, gone to there, gone to there, back to this way, over that 4 billion years. Rocks don't stay static into one mode of this triangle. They move through it in the geologic and tectonic processes. And you'll see a cross-section of a lot of these as you walk through.
So just like people, every rock has potential.
Yeah. And the rocks are the library, and the geologists are the librarians.
And the ones at the surface have more potential than the ones at the center.
Have more potential. That's good.
Higher in the gravitational field.
Kinetic energy.
So this little cartoon, and you're all familiar with the ocean plates subducting underneath the continent concept. Here's where the trenches would be out in the front of this subduction.
And the water is like here, right? That's the ocean coming against the edge of the continent. And this picture is true for Oregon and Washington, British Columbia, and all the way up into Alaska. And it's true for Central America and South America. It's only the section that the San Andreas Fault is where this has been changed.
Oblique. And then Japan, basically, when you look at the series of earthquakes that
Mount
occurred,
Fuji,
you could see
the island of Japan.
You could see the depth, the epicenter of the earthquakes diving down into the surface.
You can map that surface from the earthquake foci.
Until this all gets so molten that you're back to liquid again.
Yeah, they disappear down where they get so molten, so soft, the friction goes down, and you lose all the liquid.
So out in the ocean, you maybe have 6 or 8 miles of something that you can call terra firma. On the continent, when you're standing on top of the Sierras or top of Mount Rainier, you might have, I don't know, 15, 18, 20 miles of terra firma. So you're just floating on a sea of toothpaste, really.
And you hear the term plate tectonic theory, and theories have been, theories are constantly challenged. But this theory is a virtually brand new thing in the field of geology. It came out in the 70s, late 60s, early 70s, and really took firm in the last 30 years. And geologists all over the world have, in all sorts of complex geologic areas, have realized, God, this explains so much of what I couldn't explain before. And so it's revolutionized the geologic world, that understanding.
So this is a nicer artistic rendition of the same thing. And you can see that subduction plate and everything dies down and melts. And what's remarkable is from the depths of hell, you get these beautiful cathedrals over the top, which are just amazing. So
another important thing to note is some of the geometric relationships here. You've got the shoreline, the trench that's offshore, that from where the subduction zone is, and that distance from there to there and from there to the volcanoes is related to the plate and the angle of that plate and how far it has to get down before it melts and the lighter factions of that melt work its way back up to feed the volcanoes. And if you look at Oregon and Washington,
that string is along that line. You can almost measure it from this coastline.
If you look at a map of Oregon and Washington, all the volcanoes are about the same distance from the coast. That's part of that geometric arrangement that is forced by the plate tectonics.
That's why that trail goes so nearly
vertical through, almost linear through Oregon and Washington.
Yeah, after a while you think you're a yo-yo.
Yeah, California's all screwed up. It just wiggles all over the place, right? Sure does. California's all screwed up. We're all screwed up.
It's all because of plate tectonics.
This is Paul and I in '98, and we brought two Scottish hikers down here and thought, what can we do to give back? We've taken so much from the trail, and it's time to turn around and give back. And so from that, this event, from this situation, some of the seeds were planted that created the Kickoff.
And the Scottish folk wanted to know where the sheep were.
We didn't start at the southern terminus as you know it. We started down the valley about a mile to the east, at a little place where if you look through the steel fence today, you'll see an old cattle guard station on the Mexican side. And in 75, 76, 76, Jerry Smith, in fact a year before we did, hand painted this sign because there was no sign in those days. There was no sign, there was no way to know where you were.
That's Mexico.
To start this trail. Yeah. My first day at camp, my first camp was north of Interstate 5. Most of this was, because it was all road walking. So anyway, that's enough art history. This is a hiker photo that was given to me a number of years ago, early O's, and it's really nice. Hikers out in the desert and very fun. But what's a geologist see when he sees this photo? And so this is the sort of the observation we want to have you take away when you're out there looking at things. There's the view for the scenic beauty. There's a view for the flora and fauna, but there's a view for understanding the landforms. And what you have is a series of ridges that are coming off, and they're cut into triangular faces off the edge of this. And at the face of the bottom of those, there's an absolute straight line running across this. And there's a little bit of green vegetation all the way along that line. It's a fault line, and the water's coming up along the fault. And
So
if you're a geologist, you can see that in a photo. The person took this for a different reason. I look at it and I go, there's a fault in that picture. Yeah.
So
I think it's normal fault.
nature doesn't like a straight line. So if you see a straight line, that's something that's been disrupted. And there's some fault trend or some contact that you're looking at.
Classic geologic processes.
So rocks aren't always what they're cracked up to be. Good job.
Oh,
that's washed out, man.
Yeah, it's washed out bad. sorry. The PCT runs right along the southern, or the outflow of Thousand Island Lake. This is Thousand Island Lake from the top of Banner Peak in the Anson Islands Wilderness area, just south of Yosemite, right next to Mammoth. And it's just a classic view. One of the second slide that I showed you had Banner Peak in it, and Banner Peak's on a lot of things because it's absolutely a beautiful mountain. And it was taken from there, looking back up here, and the Ritter Range are old volcanic plugs that have been glaciated, and Ritter and Banner are beautiful examples of that. But also, there's huge indications of glacial cutting here. There's still some little, very small glaciers on Banner Peak, and they pushed out and carved this valley through metamorphics. And you can see some lineations that are like this through here, some ridges that the trees like to grow along. Those are metamorphic rocks, previously sedimentary rocks that were laid down flat prior to the intrusion of the Sierra Nevada. And they've been cooked by the intrusion, the granitic intrusion and volcanic intrusion that made the Sierras, and tilted from horizontal up to that angle. And these are called roof pendants. Is a geologic term. You don't even know that. It's just metamorphics. And you see these metamorphics all around the Sierras.
The other thing, when we had our triangle of our three rock types, we're kind of looking at that here. Banner and Ritter are a collection of volcanic and sedimentary rocks, and they've been altered and metamorphosed. And then down here you can see these concentric lines and ridges along the lake. Some of these are moraines, which were the scouring of the granites by the ice flow.
So,
and where the ice terminated for a time, it would deposit off the end of that glacier.
The big ice flow carved the valley. Little subsequent ice events, surges have pushed out and receded and pushed out. And along here, these are all forested. And there's these little mini lakes sitting in here with a circular ridge of granitic and it's just a pile of rocks that is a terminal moraine that the glacier has just pushed out.
And when you're walking along some of the meadows in the Sierras, if you got a long meadow that's in one big valley, you'll come across, there'll be a nice meandering stream, and then you'll get to a little rapids, right, where the stream does a little drop, and that's probably one of the terminal moraines. And if you look, you'll see some large boulders all collected in kind of a random stack. And then you'll get up to the next level, and then there'll be a nice meadow behind that terminal moraine, which used to be a lake behind the moraine. And you'll stair-step up through these terminal moraines as the glaciers recede.
And some of these glacial ice surges over time that have pushed the material out.
So these things have been receding. The last big surge was about 20,000 years ago. So as you see these terminal moraines moving back, as the glaciers have been receding, you'll see these events where they surge for a bit, kind of maybe like a mini ice age.
Rocks can be hazardous to your health.
Yeah, so
be careful out there.
So to a geologist, getting stoned has a totally different meaning. No, mine's always been longer than yours.
It's never been long.
Yes, absolutely. Yeah, mine's longer than yours.
Onward. So, sleep soundly for the morning.
Yeah, you just sleep with 1 foot on the ground.
Yeah. So metamorphosis transforms sandstone into quartzite, shale into slate. You're always wondering where slate came from. You get nice slate floors. It's all marine shales that were compressed, all water was compressed out of them. They were baked under pressure and temperature, and then uplifted and eroded and mined for limestone into dolomite or marble, more likely marble. Dolomite actually a geologist pointed out to me that dolomite actually has some different origins here, and it's more complex.
It has magnesium.
Anyway, but sometimes you can see the remnant sedimentary layers. They haven't melted away completely.
And these metamorphic belts that along the front of the Sierras, along the west side, is where all the gold deposits are, where that pluton was placed into the sediments, and those hot fluids that carry the heavy gold deposit in the void spaces, in the limestones and the metamorphics and so on. And that's where that's where the big nuggets are. So.
And other times the metamorphic process begins to erase the lines, the original sedimentary lines, and there's a transition from, in metamorphic rocks, back all the way to igneous rocks, where you actually start to see the crystals form again, and it completely consumes that. There's a number of places in the Sierras. One that comes to mind is as you drop on the PCT north of Donner Summit, you course along about 40 miles north of that, you drop into Sierra City. And when you switch back down that switchback, that series of switchbacks into the canyon that leads to Sierra City and the Yuba River, pay attention to what you're walking on at the top and as you go down. At the top, you're in almost perfect sedimentary rock, and as you get deeper and deeper through that cross section, the sedimentary rock becomes metamorphic rock, and then starts to transition, and then at the bottom of it, you're walking in granite. And it's that layer cake of sedimentary rock that was sitting there, the granite intruded and started to melt into the sedimentary rocks, and there's a great cross-section there that you actually switch back down through.
And then
there's a number of other ones in the trail.
There's mines in a circle all the way around that Sierra Butte, lode mines. And then there was placer all down the Yuba River and so on.
This isn't technically on the PCT, but it's a beautiful lake regardless, and it's another example of metamorphic rocks and being at high angles. These are sitting almost vertically, these, and were laid down flat into the picture and intruded and leveraged up into their vertical position.
Then you can see where they've been eroded in those canyons again and folded. You can see those dark bands. And right here on the south shore of Convict Lake is a slate. This whole thing is a slate ridge, the greatest rock skipping in the world.
Rocks have many uses.
Yeah. And skipping is the highest order.
Question?
That Mount Morrison roof pendant, I think it's kind of unusual in that the material at the top is older than the material at the bottom. Remnant of an old mountain that was then uplifted, and it's totally different material.
Yeah, the roof pendants are extremely complex. They noticed that the study of the roof pendants, all the little wisps of remnant metamorphic material that sit at the highest parts of the High Sierra through it have all been studied. And they realized that there's a group over here on the west and that all seem to hang together in geologic, lithologic types and ages and such. And there's another one over here, and there's some patches of another one over here, and another one kind of mixed in over here. And they scratched their heads about that for a long time and couldn't figure it out until plate tectonics came along and said, well, gosh, everything from about Nevada to the west is accreted terrain. It's pancake geology. It's been scraped off of the Pacific plate over the last 600 million years. And so the materials, the sedimentary rocks that are the roof pendants in the highest part of the Sierra are discrete bodies because they were scraped off the Pacific plate and then uplifted by the Sierra Nevada and glaciated and metamorphosed and then glaciated, and all we're seeing are the thin little whiffs of those left over. But you can read the tectonic history of it back by understanding all of that.
Again, it's FUBAR again. FUBAR.
Sounds like the rock equivalent of smoke.
Exactly. Wow.
Well, like many processes, we all understand the water cycles, and we understand many other cycles in our world. There's a rock cycle, and it's called plate tectonics. But every rock, as I said, is a history book, and we can read this. Sometimes the book is wide open, and you can read it beautifully. Other times the book is mostly or completely closed, and you can't even open the pages. You can only get some information on what it is now,
And I hate
not what it was.
when you're reading a book and all of a sudden there's pages missing. It's terrible.
So just looking at this photo, it's a slab of granite with a quartzite dike through it. And the geologist says, well, okay, that broke out from a higher ridge and from water freezing, erosion processes, and fell down into this meadow. And of course, prior to it breaking out, it was injected with broken and injected with a quartzite dike. But it's down in this meadow, and you think, God, it's a great place to sit down and eat lunch for backpacking. And you think it's done. It's not done. Erosional processes are still going on in this boulder. And molecule by molecule, it's being eroded into the little streamlet that's running here, that runs down into the little creek, that runs down into the San Joaquin River, that runs out through the Golden Gate into the Pacific. And molecule by molecule, over the next several 100 million years, that boulder will end up in the Pacific Ocean.
And that's why Greg's taking my ashes to the top of Mount Whitney. Because I'm doing this journey again.
We've already been on the journey. You and me and everything in this room have been on a $5 billion, $5 billion. Forget the budget. Forget the budget. Yeah.
That's nothing.
$5 billion year journey. All the molecules in our body have been recycled over and over and over. If you wanted to become part of the rock, you already have been. We didn't come from anywhere. We came from the rocks. There isn't anything in this room that didn't come from the rocks.
Including that nice synthetic tent there.
Nothing. Nothing except one small exception. The electrons coming through that light, through that window. We're terrestrial beings and everything comes out of the ground. So, damn it, where did the rocks go? That's my tent in 1977, my wood handled ice axe, Southern Sierra, Forester Pass.
Yeah, you know, there's two things about this year particularly. There's been a huge amount of snow in the Sierra.
You're likely to see Forester Pass like this.
But the other thing, because this year's been so wet, and there's other people that are more expert on this, but I've run into two things this spring already. Ticks and rattlesnakes. So I would suggest gators and maybe even long pants in thick brushy areas, and insect repellent on your legs and clothing, and tick checks every night, because Lyme disease is make Geology look like.
There's actually going to be a lady talking about Lyme disease
Yeah.
in this.
And also the rattlesnakes, they're already out, so just everybody be aware. Okay.
After the movie last night, I went over and talked to some other people, and that question that was in the film last night came up, and we were talking about our hardest day. This is my hardest day, getting over that. And you see that little wisp of that? It's a beautiful, clear day. It's about -4 degrees when I took this photo. And that little wisp of cloud was a sign of the whiteout snowstorm that hit me right when I was there. It was coming from the north, and so coming through the pass, there was this gale storm coming over my head through the pass.
Do you want to know my hardest day?
I'm afraid to ask.
It was July 4th, 1977, at Verde Falls State Park, when I ran into this guy and said, let's partner up and hike to Canada together. And that day's been going on for 34 years.
And it's going to go on for another 34 years, damn it.
If you're lucky.
If we're both lucky. So this is really pretty. Devil's Postpile, in that same area that the Thousand Island Lake banner photos. If you have an opportunity when you're near this in Red's Meadow, Devil's Postpile area, take the time to hike up the trail on top of it, because the columnar basalt has been glaciated into what I call Picasso's kitchen, because on top of the basalts are these perfectly 6- and 8-sided columns, and they've been smoothed over, polished by the glaciers that moved over, except it's not a flat kitchen floor, it does this. It's just undulating. So it's Picasso's kitchen, tile floor.
Good way to get stoned. Okay.
Donner Summit, glacial polish, you can see how rocks have been dragged along by the ice and carved grooves into the underlying granite. You see that commonly. You'll see large rocks of a totally different mythology sitting out in a meadow on all granite. And here would be a black slate rock sitting out, or metamorphic rock, and it's sitting all by itself, and all around it is granite. Where the hell did it come from? The ice brought it there.
Yeah, you look 8 or 10 miles up the ridge and you see this dark rock.
The ice carrier.
So ice is nature's D9 cat.
Every rock carries a history. This is just north of Donner Summit as well. We're kind of moving up the trail. And these pyroclastic flows go on in the Andes of South America. Commonly, you hear about them wiping out villages and such coming off the volcanoes there. There's the area around Mount Rainier is vividly aware of this. They have alarm systems all set up in the towns around Rainier. If Rainier ever heats up, they're in for this sort of disaster. When Mount St. Helens went off, there was a pyroclastic flow that came down and just made a moonscape. It took everything out.
Probably one of the most famous gas clouds and ash flows is probably Pompeii. That's a great example. Now, is this the one?
Next one.
Next one, okay.
I think. Yeah.
Pyroclastic flow, look at that jumbled debris.
So you can tell these because they're all cemented together with a matrix of like mud, looks like mud, and they're all different sizes of materials in it. It's not ordered in any way, and they're all pretty angular. They haven't come very far. The more rounded a rock is, the further the distance it's tumbled to get to that point. The more angular it is, the more immediate the erosion is. It came from right there. You can usually see it when it's this angular. It's within eyesight. If it's really round, it may be miles. It may have come miles and miles and miles to get to it.
There's a subtitle underneath here that you need to be aware of, is that rocks in this picture may appear smaller than they actually are, because we're using him for scale.
I'm not abnormal.
Yeah.
I'm normal. I'm just a normal sized human being.
People in this room may appear.
I'll talk to you later.
Northern California.
So we were looking at Donner Pass up here.
Donner Pass in there. We're going to get into the volcanics and into the Marble Mountains.
Aha, the Marble Mountain.
Skip up to the Marble Mountains. This is limestone and karst topography, where it starts to eat big holes and caves into the limestone. Some of the most famous caves all across the U.S. are all in limestones. And this is just an example of one. Paul climbed down into this one, and I'm fixing dinner with his beautiful wife, and I hear this, "Hey! Hey! I can't get out! I need some help!" And I walk over to this, and I look at it, and he's way down the hill in that way. What were you thinking when you climbed down in? You know that you'd find some gold or something? What are you doing?
Remember the picture of the subduction?
Yeah.
I was checking on my reservation in hell, so that's...
That was quick. That was quick.
You could have stopped that relationship in 25 years.
Yeah. Yeah, it's,
I wish.
You know, too late. It's,
Schist, great word, a great geologic term. Schist, you know? You can say that, not offend anybody, you know? The sun on this, the schist actually has a metallic reflection to it. It almost looks like metal. It has the micas, these silver micas that are all lined up in the same plane, and they reflect the light just almost very similar to metal. And on this day, I had to dial down my camera to get this picture because the reflection off the rocks was so intense. And then Shasta in the distance. So that's saying in that big circumnavigation through the Marble and Trinity Alps area that the PCT takes, you're always in view of Shasta in the distance.
so you're standing on the accreted terrain that was scraped off the top of the Pacific Plate, and you're looking at the melt out there to the east. It's all volcanic, mostly volcanic.
And you notice in this talk, we haven't talked about limestone until the Northern Mountains.
Yeah.
Everything south is granite and sedimentary rock, for the most part. And you get up here and you get into the Marble Mountains, and it's the first place you're getting where it's tectonically active. In other words, Shasta is there, Lassen's there, and active and hot because the subduction zone off of the coast of Northern California is still active. And you're just north of where the San Andreas fault comes and cuts off the coast. And that San Andreas system you're outside of that region. And now you're back into the classic tectonic subduction zone that is feeding the volcanoes. And this area shows the recent is what, 100 million years?
Yeah.
The recent accreted terrain that's been scraped off the Pacific Plate.
And another great gold belt, right, where you find the metamorphic. Yeah, steep terrains, rapid rates of uplift and erosion. This is Marble Mountains.
Deeves knows where this is. Is that Dead Man Lake?
Man-eaten lake.
Man-eaten Lake, that's it, yeah.
Yeah, I think that guy was there when the mosquitoes were in.
This is a picture from 77. And in 77, about 40% of California, Teddy knows this, was road walking. It was Forest Service roads, back roads, walk the roads here, Buckland Springs, et cetera. By the time we get to Northern California, we're sick of walking roads. And that whole circumnavigation of Shasta into the Marble Mountains wasn't finished yet in 77. And so we read the guidebook and it's a lot more road walking. So we decided to take a shortcut. So we head straight for the southern terminus of the
Old Oregon Skyline.
Skyline Trail. And we come across the Klamath River and come out of the little town of Wairika. And there's big signs in both sides of the highway. Highway closed 5 miles ahead. We went, we can walk by anything. And we walked around the corner and here's the bridge over the Klamath River. It's about 1,000 feet down to the river. Maybe not that, it's maybe only 600. Regardless, it'll kill you. The shopping cart down there looked about that big. And
Did you walk it?
well, we looked at the map and we said, we could walk back 3 miles to the Forest Service road that switchbacks down to the bottom and crosses the river. And we'd have to wet cross the river because there's no bridge down there either. And the river's running pretty good. And so we got to get across that with our packs and then switch back up the other side. We figured it was a good 10 to 12 mile detour, or we walk across.
Yeah,
We didn't have trekking poles.
Greg could reach this span. I had to fall to one side.
How's your balance? Is
Yeah.
it good? Keep your nose up. Yeah. Don't look down.
So, and you might ask, what does this have to do with geology? This scared the shit out of us.
Touche. What's that, 5 minutes?
5 minutes?
5 minutes. We gotta hurry.
All right,
We're in Oregon.
rushing through geological.
Only 2/3 of the way.
Okay.
So, line of volcanoes runs across Oregon into Washington. Jefferson's the foreground, and you can see, you know, 1, 2, 3, 4, and maybe 5 in the distance, right, of volcanoes, and they're all generally in the same line. You get up, as you come into the southern Oregon, you get up on the side of one of these, and you can just line sight up. And you start pulling out your map and going, oh, that's that. Okay, yeah. 2-3 days apart.
Beautiful stuff.
Whoops. Mona Falls, you saw a picture of this last night. Gorgeous, basaltic, basalt columns, I believe. Poorly formed basalt columns. Mount Jefferson, absolutely gorgeous. That was on the cover of the Oregon-Washington guidebook when we hiked. And missed name.
Yeah, this little Eagle Creek part of the trail, you can see kind of why they took people off of this. You got a mountain on one side and nothing on the other side. Each one of these old Columbia basalt flows, series of flows through the Columbia basalt, and for a short time there'd be an actual soil build up on top of these flows.
Maybe a
you can
forest.
see the trees growing out of where they could find some soil to grow in. And the trails just blasted along these series of flows. And at the end of each flow is a waterfall. And then at the bottom there's a real nice skinny dipping pool. And then another waterfall.
One of the greatest collections of waterfalls outside of Yosemite. The Eagle Creek's unbelievable.
So it's I know it doesn't go through there officially, but that's a great side trip.
You can't miss it if you like a PCT. When you're going through Tunnel Falls is one of the first falls you come to as you come out the creek and start into Eagle Creek. And you've just gone through the tunnel behind Tunnel Falls. And you're walking on wet basalt and it's all green moss and such. Come about 5 or 6 steps beyond it and look down at what you're standing on. Again, you're standing on the top of basaltic columns, just like Devil's Postpile. And if you look back at the wall below Tunnel Falls, they're all formulated in the wall of that you just walked across, and they're not always straight. And in that location, they're waving up. There's this whole grain of basalt columns that are just waving up into the exposure there. Absolutely beautiful. It's all beautiful. We've changed a little bit. Just like rocks get recycled, every molecule in our body changes. We're completely different people from that photograph. I may not have a single molecule in my body that's the same as one that...
Except he still can't grow a beard.
Yeah, and you're still short.
You didn't have enough weight in your back.
Technically.
I'm short and drunk, but I'll be sober in the morning and you'll be ugly the rest of your life. Okay, sorry about that.
I should have known. I should have known better. Okay. Washington and to the borders.
There you are.
We climb Mount Rainier. This is the Bergschrund on the top of the Ingraham Glacier. In the left-hand photo, that's Paul looking into it, and me on top, and it's really smoky. All sorts of fires burning that year because it's so dry.
You won't have that problem.
And JZ, Jeff Zimmerman's here. The 3 of us climbed Mount Rainier that year. Being the lowest snow year on record, they found an airplane crash site that the airplane had crashed 20 years before, and they recovered the remains of the bodies and laid in the rest and recovered the wreckage because it disappeared into the snows on one of the glaciers, and they couldn't find it when it went down 20 years before.
I want you to know
77, they found it.
I want you to notice the lightweight gear, the light boots, state-of-the-art packs, the cotton clothing, the cut-off blue jeans, state-of-the-art.
The 3.5-pound leather boots, the wood-handled ice axe, the ultralight rope. This was the day after we needed a badass picture because we climbed in there. This is our badass picture. So then up in Glacier Peak Wilderness, you'll see more things. There's some old copper mines up in the Glacier Peak Wilderness area, and there's been a lot of argument and political discussion about this copper deposit. And there have been forces trying to work in a mine and exploratory actions into that wilderness area for those copper deposits. And there's been some estimates that those copper deposits are so large they could materially affect our economy, sort of thing, right? In a wilderness area that is one of the most beautiful in the Pacific Northwest. And so there's huge forces on both sides doing this, and it's been going on for decades up there. But it's a beautiful area, and you can go up there and you can find azurite and other copper minerals that give that green color. That's Monty Dodge, by the way, who will be here today, I believe. He's another 77er. It just abounds. That's just over Suiattle Pass, actually to the east. Glacier Peak Wilderness area.
U-shaped glacial valley, and then you'll see all these avalanche chutes, and at the bottom will be all those jumbled piles of lumber.
Or you'll find down at the bottom of one of these avalanche chutes a boulder, and it'll be as big as this room. And it just tumbled down and took everything in its way when it came on. We were younger men then.
That was all that was at the border. And you could actually lift this sumbitch off the top of that.
Still can.
Yeah.
Oh, yeah, that movie last night, they showed it. Yeah. Yeah.
And then you can see the timberless curtains and all that kind of stuff.
Yeah.
And you can see in this picture again, I am taller than Greg.
Used to be.
And you know what? Mine's still longer than yours.
No, it isn't.
Yeah, it is.
No, it isn't.
Yeah, it is.
No, it isn't.
I'll prove it right now.
I even prove it.
Yeah.
Let's see. My pants almost fell off.
Listen, if that's an invitation, we'll talk about it later.
No thanks.
Okay.
So just remember, on a journey of 4.5 million steps,
5 million steps.
you're trod upon 5 billion years of Earth history. You're going to see a lot. You're going to enjoy a lot. You may not understand it all. Paul and I both became geologists because of what we saw hiking this trail 34 years ago. It spurred us to ask the questions, to want to understand. And that's why we're both geologists and professionally
And so,
employed still.
since we're running out of time, we're hanging out over there by the front. If you guys want to talk geology or anything else, we'd love to.
Yeah. Any questions you want, we'll take it outside here or at